this section we're going to focus on matrix multiplication. Now, matrix multiplication is simple. It's just a process. Now remember, simple doesn't mean easy. Simple is just, it's an algorithm, it's a process. And doing this, we're going to just focus on the pattern at first. So let's just watch the process, and then let's go back and see if you've picked it up. Now, how it's going to work. In the first matrix, we're always going to focus on rows. So row 1, row 2. On the matrix on the right, we're always going to focus on columns. Column 1, column 2, and column 3. Now, how the process works, we're going to pick one row and one column at a time, and we're going to have to go through all the different combinations. So I'm going to start with row 1 and column 1. Now, how the multiplication is going to work is we're going to match up values. So now it's like you're reading. So and I would point with my fingers, but you can't see them. So we're going to start with the first number in the row and the first number in the column. So it's like you're reading. When you're reading, you start from the left and go to the right. When you're reading, you start from the top of the page and go down. So in rows, you start from the left. From columns, you always start from the top. All right, and we're going to match up these two numbers. 1 times 0, and you're going to multiply them. So 1 times 0 makes 0. Okay, then the next two numbers would be negative 4 and 1. So notice we move both values. We're moving both. Now we use the second number in the row and the second number in the column. So negative 4 times 1 makes negative 4. And then last, the third number in both the row and the column, 3 times 2 makes 6. Now, to finish up this process, you're like, now I've got three numbers. What do I do with these? Well, to finish these up, we're going to add all of these numbers. So 0 plus a negative 4 plus 6 makes 2. So that is going to be our entry into our matrix. That is our answer. So after a while, we'll skip this middle part. We won't write out all the adding and the individual numbers. We'll just add them up in our head and move along. Now, how do we know where that's going to go in our answer matrix? Well, it goes in the same place that is being described right here. Our answer is going to go in row 1, column 1. So if you kind of think of it as, we don't usually write these, but I'm just writing kind of a little blank so we can kind of remember. This would be our 1, 1 entry. So let's get rid of that though. Okay, so now let's do another one and see if we can kind of fill all this stuff in. All right, so now I'm done with that combination. I've done row 1 and column 1. So now let's pick another combination. Why don't we do, well, we'll have to do them all, but why don't I do row 1 and column 2? Okay, so I'm going to use these numbers again, all the numbers again, and then I'm going to use those numbers. So now here comes the same process. Start from the left, start from the top. 1 times 2, and that's that entry. So now this 1 times 2 would make 2, plus negative 4 times 4, which makes negative 16. I didn't leave enough space here. And then 3 times negative 2 would make negative 6. So I'm going to give myself a little more space. Don't you wish you could do this on paper? Whoops. Let's try that one more time. Maybe you don't wish you could do that on paper. There we go. Okay, so those would add up to make, let's see, negative 16 plus a negative 6, which would make negative 22. Negative 22 plus 2 would make negative 20. So that means my next entry in my matrix would be negative 20. And what is its position? Well, it's going to go in row 1, column 2. So again, here's our first row, row 1, column 2. All right, so there you go. Let's do another example here. All right, so now, just for the fun of it, now you could go over to column 3 and keep going in that pattern, but just to see if we're getting this, why don't we jump around a little bit? Let's jump to here and go row 2, column 2. Let's do that, mate. Let's do this set of numbers, that one and that one. All right, so start from the left, start from the top, always do that. So 2 times 2 makes 4. Now we have to think about where is this going to go. So right now, row 1, this would be column 1, this was column 2. So where is this going to go? Well, since we're doing row 2, that means my answer is going to have a row 2. And it's going to go in column 2. So it's going to go right below this other answer. Okay, so 2 times 2 makes 4. My next entry would be 9 and 4. So 9 times 4 is 36. And then my last set of numbers here will be 5 and negative 2, which makes negative 10. And then I take all these values and add them. So let's see, 4 times 36, 4 plus 36 would make 40. 40 minus 10 would make 30. So there we go. So row 2, column 2, there's my answer. So you can see we still have 3 answers to go. So I would highly recommend pause the video, fill them in, and give it a shot. I'm going to do one more, so just in case. But if you're feeling good about this process, you can skip through a little bit of the video here and see if you get the same thing I'm getting. Okay, so I'm going to do for this next one, this last one I'm going to do here in this particular problem. We're going to start with row 2, column 3. So row 2, column 3. Sorry, that's not row 3. Try again. Column 3. Much better. Okay, so we match up our first number and our first number, right? Always start from the left, always start from the top. 2 times 7 is 14. Next set of numbers, 9 and 0. So 9 times 0 makes 0. Last but not least, 5 and 5. So that makes 25. So 14 plus 0 plus 25, that makes 39. So that's going to go right here because this is our first entry in our third column. So it's row 2, column 3. So we put it in our answer matrix of row 2, column 3. So there's 2 numbers left. You know what? I'm going to just do them on the video. But again, please feel free to skip through them if you are already beyond and got this. Okay, so let's do this entry here. Let's do row 2, column 1. So row 2, so we're going to use row 2 and column 1 in my column matrix. Okay, so 2 times 0. 2 times 0 makes 0 plus 9 times 1, so that makes 9. And 5 times 2, so that makes 10. That adds together to make 19. Last entry, here we go, row 1, column 3. All right, so let's highlight the rows we need. We are going to be using row 1 and column 3. Okay, so 1 times 7 makes 7. Negative 4 times 0 makes 0. And, 1 times 7, there we go. Negative 4 times 0. And last but not least, 3 times 5. That makes 15. So 15 plus 7, that makes 22. So there we go. There's our answer matrix. All right, so now let's talk about how we got here and some of the key components. Now, again, most of the time you're going to skip this entire middle thing. We're not going to write all that out. You're just going to add up, or you can do a little bit of scratch paper, a little bit of side work and add up the numbers on the side, but you're just going to jump straight to your answer. Now, let's talk dimensions. Let's talk dimensions. The original matrix here was the one on the left was dimensions. Remember, it goes rows by columns. So the dimensions here were 2 rows and 3 columns. Okay. Now notice here, the second matrix had 3 rows and 3 columns. Now, what made this work was, if you think about it, these numbers matched. Because what are we saying here? The fact that we had 3 columns, 1, 2, 3, meant as I'm going across my row, I used 3 numbers each time. And then the fact that this one had 3 rows meant that as I was going down my column, I had 3 numbers each time. So those matched, which meant I could pair them up. So I would say this one with this one, the negative 4 with the 1. So that's what made it work. If those numbers didn't match, we would have a problem. Okay, and in fact, you wouldn't be able to do the multiplication. You have to say that it's not possible. The answer does not exist because you wouldn't have a match. And we'll see one of those examples in a minute. Um, Now, look at our answer matrix. What were the dimensions of this? It is 2 rows and 3 columns, so it's a 2 by 3. If you look back, the outer numbers tell us the dimensions of our answer matrix. Because if you think about it, it's just saying, okay, those came from us building the whole matrix by saying, all right, all of my answers, if it's coming from row 1, are going to go in row 1 of my answer matrix. And if it's coming from row 2, it's going to go in row 2 of my answer matrix. So it's just saying our rows will determine the answer matrix, rows. And here, the number of columns that our second matrix has, column, I keep doing that. Column 1, column 2, column 3 determines how many columns our answer matrix has. Ooh, I lost my number. Where did that go? Let's put that back. So let's see, negative 16, negative 22, negative 20. There we go. Okay, so that's the idea. That's the idea. So the dimensions are helpful because they tell you, the inside dimensions tell you can it be done. The outside dimensions say yes if it can. Here's what your answer will be. So let's go down here and look at this one. Right, so the first thing I always do whenever I do one of these problems is I start off with the dimensions. I start off by saying, all right, this one has how many rows? 1 row and 2 columns. This next matrix has 2 columns and 2 rows. So I first want to start off and saying, is it even possible? Well, because they match, yes. Each of our values when we multiply are going to have 2 numbers to multiply. So we're good. So yes, there is an answer. Now, what is the dimensions of our answer? The dimensions is a 1 by 2. So we can now already kind of write out our matrix and say, okay, it's going to have 1 row and 2 columns. All right. So now I challenge you, pause the video, try it yourself. But I'm going to walk through this last one more time because sometimes this is called a row matrix because it only has 1 row. But sometimes that throws people off a little bit. I'm not too terribly concerned about it, but I want to make sure I walk through it just in case somebody needs to see it one time. But otherwise, pause the video, try it yourself, fast forward, see if you got it right. Okay, here we go. 4 by 3, row 1, column 1. So 4 and 7. 4 times 7 is 28. And 2 times 3, that makes 6. So those are going to add together. So 28 and 6, which would be 34. All right, so there's my row 1, column 1 answer. So now I got to do row 2, column 2. Sorry, row 1, column 2. So here we go. Row 1, column 2. All right, so we take our values here. First value, 4 times 4 is 16. Second value in the row, second value in the column. That's 3 times negative 1, which makes negative 3. So that will make 13 plus a negative 3, or sorry, 16 plus a negative 3 makes 13. I already wanted to get to the answer. There we go. And you can see our dimensions here of our final matrix was a 1 by 2, just like we said. 1 row, 2 columns. So that's it. That's all there is to matrix multiplication. Now, take a quick look at this one. Do you write out your dimensions? So this one is a 2 by 2. This one is a 1 by 2. What do you notice? What do you notice? Yeah, it can't be done, can it? And it doesn't make sense. Like if you try to do row 1 and column 1, when you go to pair these numbers up, you say, okay, 7 times 4, all right, great. But now I got to move on. Second number, wait, there is no second number. There's nothing there. It's missing. So therefore, what we'd say is this has no solution. It can't be done. Now, the next thing I want to point out, though, is do you notice that and this are the same matrices? All I did was switch the order. Whoops, come back. So what does that mean? There's something very important there. something incredibly important here. If you kind of think of it as this is A times B, and this is B times A, and notice they don't have the same answer. So something very important to understand about matrix multiplication is A times B does not equal B times A. This is the first deviation we've seen from like regular algebra, where normally in algebra, 3 times 4 is equal to 4 times 3. It's commutative. You could change the order all you want. Well, in matrix multiplication, that's not the case. The order is extremely important. So you can't change. If the matrix is on the left, it has to stay on the left. If it's on the right, it has to stay on the right. You can't mix them around just to make it convenient. All right. So that was by hand. That was by hand. Now, you are going to have to do things by hand in the next section. But in the next video, I'm going to walk you through using your calculator. But I just want to give you a little break on this video. All right, I'll see you in the next video.